Alright, so we're going to work now on lesson 7, and you can highlight the title. This is called the discriminant.
Can I like this or only this?
3.
Three? Okay, I'll change this.
You can put 4 actually. You saw your mistake, right? So just highlight this for me, guys, the discriminant. There's probably 4 or 5 marks on the test for the discriminant. So while this particular lesson doesn't have a lot of difficult understanding to it, there is a few questions dedicated to it on the test. So just a quick review of what we've been doing. I like that the book does this. Just a little snapshot of what we've been doing. The goal, basically, like if you're trying to think of like why are we even doing this, the goal here is to find roots. Okay, you're trying to find x-intercepts. You're trying to find solutions to a quadratic equation. And there's lots of ways you can do that. There's 4 ways now that you have under your belt. Okay, so do it by graphing. This would be calculator. Okay, so go ahead and type it into your calculator. Where does it go? Y1. Quick little review for your calculator. Uh-oh, my calculator is frozen. Frozen in time. Okay, where do I put my formula? Y1, okay, what was it? X squared minus 8x plus 12. And then before I hit window or graph, I'm just going to hit zoom 6. That way I'll just look at it on my standard window. Oh, this one actually looks pretty good. See, this is 2 and this is 3, 4, 5, 6. So let's graph that. Doesn't have to be perfect. We know that it's going to hit 2 and 6. Okay, and then the next 2 boxes on the right, can you guys do those right now on your own? Okay, so let's see what you guys got. This one you could factor by inspection, and the 2 are -2 and -6, which is obvious if you think about the solutions to the graph over here on the left. The 2 solutions are 2 and 6. Is that better? And then the quad formula, you guys have had some experience with this now. So -b, what's that going to be there, Fred? Plus 8, Fred? All over, or plus or minus the square root of b squared, which is 64, right? Minus 4ac, so 4 times 1 times 12, all over 2a, 2. Okay, so you have 8 plus or minus 64 minus 48 is, thank you, all over 2. So it's 8 plus or minus 4 over 2. So the 2 answers are 8 plus 4 over 2, and the other one would be 8 minus 4 over 2, and those are 12 over 2, which is 6, and 4 over 2, which is 2. Just like we expected, right? x1 and x2. And then the completing the square, this is the one where maybe you might have had a hiccup. Hopefully you gave it a try. This is probably the least used version for these 4 options. But again, very powerful strategy. So what do we do with that middle term? cut it in half and square it, so 4 becomes 16 minus 16. And then the first three terms, if you keep the plus 16 first, right? Always the plus first. Those three terms are going to make the perfect square x minus 4. And then you combine the outside, which is minus 4. Okay, and we're saying that all this is equal to 0, right? All this is equal to 0. So then take that 4 to the other side. Square both sides. Not square both sides, square root both sides. Square root both sides, and then you get x equals plus or minus 2 plus 4. So the two answers would be positive 2, positive 4 gives positive 6, and negative 2, positive 4 gives positive 2, just like we expected. Which is your favorite? Top left? Unless you hate using the graphing calculator. Bottom right, yeah, bottom right is probably the easiest and the most guaranteed. If you have something very bizarre and you're like, these numbers are too big, I wouldn't try factoring it right away. If you see regular numbers that you're used to, like you can spot the pattern, just jump into your factoring right away. And then in general, if it's crazy, use quad formula. But also, you're stuck, use the calculator to help you. The only thing the calculator won't give you is the exact values, especially if it's like irrational. But the calculator gives you a nice place to start. And then completing the square depends how much you like that strategy. Oh, so that's what we were just doing here. So graphing, always, except no exact values. So do not do this in your written response. That says don't do it in the written response for graphing. Completing the square is powerful. It's always acceptable. Except the only problem is it might be hard for some of you. It might be hard to get to the vertex form to make this happen. Yeah, it has to be in this form, this right here. That's the vertex form. In order to get there, you have to complete the square. The one we did in the example was quite easy. There's some that are very hard. There's fractions and big numbers, and you might get frightened. So probably the two best ways are factoring, if you can factor. How do you know you can factor something? Those magic numbers have to work, right? You have to be able to find those two magic numbers. So in general, probably the best way is quad formula because it always works and it's not that hard. Quad formula, woo! It always works, and as you can see, there's not a lot of difficulty to it. Let's move on. Class example 2, you're not going to see this on your test at all. All this is trying to show you is that you have to be in this form to use the quad formula. You have to be in this form. And as you can see here, this is not. There's a lot going on with this. We shouldn't even, I don't think this is even a fair question. Because like, you know, the fact that A can't be 0, why can't A be 0? Shh. Because then you would be dividing by 0 and then Cookie Monster's upset and you have no friends. You guys ever listen to that? Okay, so there's a restriction. So I guess this is fair. This is a domain restriction. But the idea here is you don't have this form. So what would you multiply everything by to make it that form? Good. So then you'd have 2 plus 3a equals minus a squared. Because what's happening is you're going to put a squared in the top on all of these by multiplying through. So then those would cancel. Only 1 would cancel here, and none will cancel over there. And then bring everything to the one side so that the lead coefficient is positive. And then even just rearrange it so it's more comfortable in the right order. And then you can go ahead and use the quadratic equation. Okay, so negative b plus or minus b squared would be 9 minus 4 times 1 times 2. So this is actually a nice one. All over 2 times a, 2 times 1. So you get negative 3 plus or minus root 1 over 2. Negative 3 plus 1 over 2, or negative 3 minus 1 over 2. Looks like negative 2 over 2, negative 4 over 2, negative 1, negative 2. Okay, so I went a little bit fast, but you've had some practice with the quad formula now. I sort of skipped a step on the substituting, but I think at this point you guys should be okay with that. And just double check the key, make sure I didn't lose my mind. Okay, now once the lesson quiz class example 2 is finished, you're now into like the start of the lesson. Like the start of the lesson is really right here. What is the discriminant? So back to the title, you can see right here, this is what we're doing, the discriminant. And you need to know this. This is 4 or 5 marks on the test. Okay? Okay, so let's take a look at the nature of roots. The nature of roots, I would highlight that. Because on the test, it'll say, what are the nature of the roots? And all they're asking is like, if you were to draw a quadratic, what are all the possibilities for that quadratic? How many intercepts could you have? At most, you could have, at most 2. Could you have 1? How do you draw that? It only touches at one spot. So there's 1. And is there a possibility where there's none? Yeah, that's like if the vertex is hanging out in empty space out here like this. 0. 0 zeros. Okay? So what we're going to find out is that the discriminant, which is in fact this thing under the radical, can give us that for free. So let's check out these 3 equations. So what's the first discriminant? And I'm going to highlight that. This is what I'm referring to as, this is the discriminant. So what's that first discriminant work out to? B squared, so 36, minus 4 times 1 times 5. 20, so 16. So you get plus or minus 4. And the 2 roots are 5 and 1. Any questions about that? 36 minus 20, 16. So you get 4 and negative 4. 6 plus 4 is 10. 10 over 2. 6 minus 4, 2 over 2. Okay, and then you can see is it at 5 and 1? Yeah. Okay, 5 and 1. Okay, so let's do the next one. And before we move on, let's just highlight the fact that we just had like a positive number that worked out perfectly. So let's go to the next one. Let's take a look at the next discriminant. B squared would be 36 again, minus 4 times 1 times 9, 36. So 36 minus 36 is 0. Square root of 0 is positive 0, negative 0. So it's 6 over 2 is 3, and 6 over 2 is 3. What happened? Touched once. So you can see touches once. So we got 2, 1, and none. We're not even there yet, but you guys should already know what's going to happen with this. It happened on the quiz. You guys remember what happened? You had a negative radicand, right? So b squared 36 minus 4 times 1 times 13. What's 4 times 13? 26 and 2 will be 50. 52. 36 minus 52, just help me. 46. 16. Negative 16. So you can't take no real solution here. You can't take the square root of a negative in the real numbers. So the roots don't exist. Doesn't exist. Doesn't even grammar. That grammar is bad, but whatever. No, not an English class. So we have the 3 situations for the zeros. Okay, so make the connections here. Okay, so you can see if you have two x-intercepts, then your radicand is just a positive number. If you have 1, then you can see that the discriminant, the radicand, is 0. That'll always be the case. And then none is if you have a negative radicand. Riveting stuff, hey Emily? Made you yawn. Okay. The graph 1, graph 2, graph 3, I just summarized. So in math, they have these like fancy words. That's basically what this is. Okay, so real just means like element of real. And then they're unequal. And a better word for unequal in math is distinct. It just means that they're different. Distinct. Like if you look at me and you look at Shaq, like you can tell us apart. We're distinct. We're distinct, right? But if you put me like next to Brad Pitt, it's really hard to. Tom Cruise, it's really hard to tell us apart, you know. Nicolas Cage. Okay, so the next one for graph 2, this is real and equal. So you think of like there are 2 roots, they're just the same. So there's 1 root, right? There's 2 roots, but they're the same. So the 2 roots are real and equal, so essentially there's 1 root. And then in graph 3, non-real, this is just like not an element of the real. That's all that is right there. So again, they're going to formally put the discriminant here for you as basically the radicand in the quad formula. So like don't make this harder than it needs to be. Like the quad formula is pretty easy to use, and there's a really distinctive feature about it, and it's what's inside that radical. So that's like the distinctive feature. Just like a radius is the distinctive feature for a circle, this radical is the distinctive feature for this quad formula. So what's the most important part of the quad formula? The discriminant. You can actually just analyze the discriminant and figure stuff out real quick. So let's take a look at these examples. Or is this previous page? Okay, so let's just copy this down. What's the point of this? The chart, can you guys, I'll just use my key because we're just copying work we've already done. Just so your books are nice. 16 positive. 0, 16 negative. Nature of roots, real and distinct. Real and non-distinct, equal. And then non-real. The roots were 1, 5, 3, 3, and not applicable. Okay. So more importantly is part B. This is way more important. Just copying from the previous examples, wasting my time. But anyways, complete the following. If the discriminant is 0, then the roots are real. Go to the next one. If the discriminant is positive, the roots are real. If the discriminant is negative, the roots are non-real. If the discriminant is 0, then they're going to be equal. If the discriminant is positive, then they're going to be distinct. All right, now hopefully we can actually start doing some math here. What? No, that's it. Time for math. Okay, so on the test, if you see this, then you know you just look at the discriminant. So all you care about is b squared minus 4ac. Okay, so we have negative 1 squared minus 4, 6, negative 1. You get 1 plus 24, you get 25. So what do you say? Real and distinct. So you'd say oh my gosh. In other words, two solutions. That's how I would, like if I was to make my own math book, I would just say two solutions. I wouldn't have that real distinct stuff in there. Because sometimes you just want to pick out like what really matters here. But whatever, this is good stuff too. So here we go. What's the next one? Well, before I can start analyzing the next one, it's got to be in the form that I'm used to. Let's just quickly make that adjustment, move that 8x over. Now we can jump into the discriminant. B squared minus 4ac. So b is negative 8. So square that, you get 64. And then 4 times 1 times 16. 4 times 16, 64. So you get 0. So if it's 0, then it's real and equal. In other words, there is one solution. Good. Now what do you think the last one's going to be? Smart people in here. Okay, let's just do this one quick. B squared. Oops. B squared would be 4. 2 times 2. And then 4ac. 4 times 5 times 1. 20. Negative 16. Discriminant is negative. Non-real. No solution. Yeah. Oh, class example 5. It's on the test. Ask Chi Ming, he wrote it. Just start sliding Chi Ming some money under the table. Oh, no, what he wants is actually he wants Apple credits so he can upgrade his troops. Just give him the envelope full of money. All right, so it says determine for what values of m would this quadratic equation have real and distinct roots. So what do you have to be, what does the discriminant have to be to have real and distinct roots? Has to be positive. So you'd write this. B squared minus 4ac has to be positive. What if you wanted real and equal roots? Then b squared minus 4ac would have to equal 0. Good, Emily. And the last one, b squared minus 4ac would have to be less than 0. And Chiming, actually, I'm sorry you got this one wrong on the test. Because he forgot to do this. He was trying to solve, I looked at his work, he was trying to solve the whole quad formula equal to 0 instead of just the discriminant. Okay? Okay, so what's b squared? 64. Okay, minus 4, what's a? 1, and then c is m. Okay, so all that has to be bigger than 0. So 64 minus 4m has to be bigger than 0. Do you remember solving these a while ago? About a month ago? Should we move the 64 over or the 4? Good. What happens if you move the 64? Then you'd have to switch a sign, and that's just nasty, so don't do that. Divide by 4 and you get 16? So as long as m is less than 16, you'll have real and distinct roots. Now, it's going to be the exact same work, but just equals. So 64 minus 4m equals 0, so m equals 16. So when m is 16, then you'll have one root. And you'll notice that this would make it a perfect square. So you'd have the factoring for x squared minus 8x plus 16 would be x minus 4 all squared. So what are the roots of this? There's only one root, right? X equals 4. Okay. Yeah, but I'm just trying to show you that when do you have real and equal roots? When you have a factoring that is a perfect square. It's only those rectangle factorings. The length and the width are different, right? Per squares, length and the width are the same. So then this one will be identical to the other one, except it'll be, instead of m less than 16, you notice the pattern here. You got less than 16, at 16, so this one logically would be more than 16. Good. Okay, and if you want to show all that, you'd have 64 minus 4m less than 0, 64 less than m, 4m, divide by 4, and you get m greater than 16. Super fun times. And I'm not going to worry about class example 6. You'll have nothing that nasty in the on the test, and I don't want to burden you with too much. So, guys, these two examples, like, big time on the test. 4 or 5 marks in the multiple choice. Okay? Okay? Everyone's got this? Even Jolene? Put a star. MC? Star MC. Multiple choice. Study the discriminant. That's a star. EMC square? Oh! Okay, so for the Yeah, the assignment looks nasty. Like, form an equation and solve. So, if you had to prioritize time, 4 and 5 and 6, okay? If you had to prioritize time, I would at least expect that you'd try a few of these on the first page. But the big focus is the second page, 4, 5, 6. Okay, if we're trying to maximize time and effort towards percentage points, I know that's what life's all about. So 4, 5, 6. Okay? Enjoy your life.
What are you doing tomorrow after school?
Going home. Why?
Well,
Let me just stop the video.